Right, hey everyone again. Welcome back to Neural and Wires. We finally reached the last video of this tutorial series and wow, what a journey it has been, guys. We built very good project throughout this series. We built our very own language model from scratch using PyTorch, and we took a deep dive into every fundamental concept behind it. So what we covered in this series, let's quickly recap all major steps we went through to build our very own Bigram language model. Guys, so first we downloaded and prepared our dataset. We started by replacing our dataset with the one that we prefer. So I preferred a doll's house and explained how to work with custom datasets. We learned how to read text files and pre-process them into a structured dataset for training, and we understood character level tokenization and encoding. We explored how text data is transformed into numerical representations using character to integer mappings. We implemented encoding and decoding functions to convert between text and numbers. And guys, we learned how to store them in PyTorch tensors, and we used PyTorch tensors to store and manipulate large dataset efficiently. We split the data set into training and validation sets, and we also did batch processing and data pipeline. We created a batching function to train on multiple sequences simultaneously, speeding up our training process, and we implemented context windows to train our model on sequences of characters. Guys, we constructed a Bigram language model that predicts the next character based on the previous one. We used an embedding table to learn character relationships. We walked through matrix multiplication tricks to create a weighted aggregation of past inputs. We implemented softmax normalization to ensure probability distributions are well formed. We introduced the concept of self-attention and how transformer models use it to process input sequences. Guys, we also did we replaced batch normalization with layer normalization to stabilize training. We added multi-head attention feed forward networks and transformer blocks to improve learning efficiency. We trained our model on the dataset and observed loss values decreasing over multiple training iterations. And finally, we used our trained model to generate text and saw our AI trying to mimic the style of a doll's house. So guys, where you can find this code, the complete source code for this project is available on my GitHub repository, and you can download the code, modify it, and even experiment with your own data sets. So one of the coolest things about this project is that you can train this model on any text dataset you want. Here's how you can do it. Just replace the input text with your own data set and adjust the vocabulary size by extracting unique characters from your dataset. Train the model from scratch with your dataset by running the script. And guys, so final thoughts, what we built in this series is incredible. So we implemented a real neural network based language model from scratch, and we understood every step along the way. You now have a strong foundation in PyTorch basics and character level language modeling, tokenization and embeddings, attention mechanisms, model training and optimization, and most importantly, you now have a project to showcase on your portfolio. If you enjoyed this series, don't forget to like, subscribe, and hit that notification bell for more advanced AI and machine learning content. So guys, this is Neural and Wires, and I'll see you in the next project. Keep coding and keep innovating. Until next time, happy coding. You guys are rock, and I gotta roll.